This photo shows many different pairs of shoes in various colors. The shoes appear to be hanging from a wall by cords. Figure 6. 1. If you ask enough people about their shoe size, you will find that your graph data is shaped like a bell curve and can be described as normally distributed. Credit, modification of work, shoe shop by Low Flicker, public domain. Chapter objectives. By the end of this chapter, the student should be able to recognize the normal probability distribution and apply it appropriately. Recognize the standard normal probability distribution and apply it appropriately. Compare normal probabilities by converting to the standard normal distribution. The normal, a continuous distribution, is the most important of all the distributions. It is widely used and even more widely abused. Its graph is bell-shaped. You see the bell curve in almost all disciplines. Some of these include psychology, business, economics, the sciences, nursing, and, of course, mathematics. Some of your instructors may use the normal distribution to help determine your grade. Most IQ scores are normally distributed. Often real estate prices fit a normal distribution. The normal distribution is extremely important, but it cannot be applied to everything in the real world. In this chapter, you will study the normal distribution, the standard normal distribution, and applications associated with them. The normal distribution has two parameters, two numerical descriptive measures: the mean mu and the standard deviation sigma. If x is a quantity to be measured that has a normal distribution with mean mu and standard deviation sigma, we designate this by writing. This diagram shows a bell-shaped curve with the lowercase Greek letter mu at the center of the x-axis. It has the label normal. Uppercase X is similar to n mu sigma. Figure 6.2. The probability density function is a rather complicated mathematical function. Do not memorize it. It is not necessary. Fx equals 1 letter 1d70e, 2 letter 1d70b square root, e minus 12, letter 1d465 minus letter 1d707 letter 1d70e2. The cumulative distribution function is p, xx. It is calculated either by a calculator or a computer, or it is looked up in a table. Technology has made the tables virtually obsolete. For that reason, as well as the fact that there are various table formats, we are not including table instructions. The curve is symmetric about a vertical line drawn through the mean mu. In theory, the mean is the same as the median, because the graph is symmetric about mu. As the notation indicates, the normal distribution depends only on the mean and the standard deviation. Since the area under the curve must equal 1, a change in the standard deviation, sigma, causes a change in the shape of the curve. The curve becomes fatter or skinnier depending on sigma. A change in mu causes the graph to shift to the left or right. This means there are an infinite number of normal probability distributions. One of special interest is called the standard normal distribution. Collaborative exercise. Your instructor will record the heights of both men and women in your class separately. Draw histograms of your data. Then draw a smooth curve through each histogram. Is each curve somewhat bell-shaped? Do you think that if you had recorded 200 data values for men and 200 for women that the curves would look bell-shaped? Calculate the mean for each data set. Write the means on the x-axis of the appropriate graph below the peak. Shade the approximate area that represents the probability that one randomly chosen male is taller than 72 inches. Shade the approximate area that represents the probability that one randomly chosen female is shorter than 60 inches. If the total area under each curve is 1, does either probability appear to be more than 0? 5. The standard normal distribution is a normal distribution of standardized values called z-scores. A z-score is measured in units of the standard deviation. For example, if the mean of a normal distribution is 5 and the standard deviation is 2, the value 11 is 3 standard deviations above, or to the right of the mean. The calculation is as follows. X equals mu plus z, sigma equals 5 plus 3, 2 equals 11. The z-score is 3. The mean for the standard normal distribution is 0, and the standard deviation is 1. The transformation z equals letter 1d465 minus letter 1d707 letter 1d70e produces the distribution z n0, 1. The value x in the given equation comes from a normal distribution with mean mu and standard deviation sigma. Z-scores. If x is a normally distributed random variable and xn, mu sigma, then the z-score is letter 1d467 equals letter 1d465. The z-score tells you how many standard deviations the value x is above, to the right of, or below, to the left of the mean mu. Values of x that are larger than the mean have positive z-scores, and values of x that are smaller than the mean have negative z-scores. If x equals the mean, then x has a z-score of 0. Example 6. 1. Suppose xn 5, 6. This says that x is a normally distributed random variable with mean mu equals 5 and standard deviation sigma equals 6. Suppose x equals 17. Then, letter 1d467 equals letter 1d465, letter 1d707, letter 1d70e equals 1756 equals 2. This means that x equals 17 is 2 standard deviations, 2 sigma, above or to the right of the mean mu equals 5. Notice that 5 plus 2, 6 equals 17. The pattern is mu plus z sigma equals x. Now suppose x equals 1, then z equals 156, equals 0, 67, rounded to 2 decimal places. This means that x equals 1 is 0, 67 standard deviations, 0, 67 sigma, below or to the left of the mean mu equals 5. Notice that 5 plus 0, 67, 6, is approximately equal to 1. This has the pattern mu plus 0, 67, sigma equals 1. Summarizing, when z is positive, x is above or to the right of mu, and when z is negative, x is to the left of or below mu. Or when z is positive, x is greater than mu, and when z is negative, x is less than mu. Try it 6-1. What is the z-score of x when x equals 1 and x in 12-3? Example 6. 2. Some doctors believe that a person can lose 5 pounds, on the average, in a month by reducing their fat intake and by exercising consistently. Suppose weight loss has a normal distribution. Let x equals the amount of weight lost in pounds by a person in a month. Use a standard deviation of 2 pounds. X in, 5, 2, fill in the blanks. Problem. A. Suppose a person lost 10 pounds in a month. The z-score when x equals 10 pounds is z equals 2.5. Verify. This z-score tells you that x equals 10 is standard deviations to the right or left of the mean. What is the mean? Solution. This z-score tells you that x equals 10 is 2.5 standard deviations to the right of the mean 5. Problem. B. Suppose a person gained 3 pounds, a negative weight loss. Then z equals. This z-score tells you that x equals 3 is standard deviations to the right or left of the mean. Solution. Bz equals 4. This z-score tells you that x equals 3 is 4 standard deviations to the left of the mean. Problem. C. Suppose the random variables x and y have the following normal distributions: x in 5, 6, and y in 2, 1. If x equals 17, then z equals 2. This was previously shown. If y equals 4, what is z? Solution. Z equals letter 1d466 minus letter 1d707 letter 1d70e equals 4 minus 21 equals 2, where micro equals 2 and sigma equals 1. The z-score for y equals 4 is z equals 2. This means that 4 is z equals 2 standard deviations to the right of the mean. Therefore, x equals 17 and y equals 4 are both 2 of their own standard deviations to the right of their respective means. The z-score allows us to compare data that are scaled differently. To understand the concept, suppose xn5, 6, represents weight gains for one group of people who are trying to gain weight in a 6-week period, and yn2, 1, measures the same weight gain for a second group of people. A negative weight gain would be a weight loss. Since x equals 17 and y equals 4 are each 2 standard deviations to the right of their means, they represent the same, standardized weight gain relative to their means. Triad 6-2. Fill in the blanks. Jerome averages 16 points a game with a standard deviation of 4 points. Xn 16-4. Suppose Jerome scores 10 points in a game. The z-score when x equals 10 is 1.5. This score tells you that x equals 10 is standard deviations to the right or left of the mean. What is the mean? The empirical rule. If x is a random variable and has a normal distribution with mean micro and standard deviation sigma, then the empirical rule states the following. About 68% of the x values lie between 1 sigma and plus 1 sigma of the mean micro, within 1 standard deviation of the mean. About 95% of the x values lie between 2 sigma and plus 2 sigma of the mean micro, within 2 standard deviations of the mean. About 99.7% of the x values lie between 3 sigma and plus 3 sigma of the mean micro, within 3 standard deviations of the mean. Notice that almost all the x values lie within 3 standard deviations of the mean. The z-scores for plus 1 sigma and 1 sigma are plus 1 and 1, respectively. The z-scores for plus 2 sigma and 2 sigma are plus 2 and 2, respectively. The z-scores for plus 3 sigma and 3 sigma are plus 3 and 3, respectively. The empirical rule is also known as the 68-95-99-7 rule. This frequency curve illustrates the empirical rule. The normal curve is shown over a horizontal axis. The axis is labeled with points s, -2s, -1s, m, 1s, 2s, 3s. Vertical lines connect the axis to the curve at each labeled point. The peak of the curve aligns with the point m, figure 6.3. Example 6.3. The mean height of 15 to 18-year-old males from Chile from 2009 to 2010 was 170 cm, with a standard deviation of 6.28 cm. Male heights are known to follow a normal distribution. Let x equals the height of a 15 to 18-year-old male from Chile in 2009 to 2010. Then xn 170 628. Problem. A. Suppose a 15 to 18-year-old male from Chile was 168 cm tall from 2009 to 2010. The z-score when x equals 168 cm is z equals. This z-score tells you that x equals 168 is standard deviations to the right or left of the mean. What is the mean? B. Suppose that the height of a 15 to 18-year-old male from Chile from 2009 to 2010 has a z-score of z equals 127. What is the male's height? The z-score, z equals 127, tells you that the male's height is standard deviations to the right or left of the mean. Solution. A. 032, 032, left 170. B. 177. 98 cm, 127 right. Triad 6.3. Use the information in example 6.3 to answer the following questions. Suppose a 15 to 18-year-old male from Chile was 176 cm tall from 2009 to 2010. The z-score when x equals 176 cm is z equals. This z-score tells you that x equals 176 cm is standard deviations to the right or left of the mean. What is the mean? Suppose that the height of a 15 to 18-year-old male from Chile from 2009 to 2010 has a z-score of z equals 2. What is the male's height? The z-score z equals 2 tells you that the male's height is standard deviations to the right or left of the mean. Example 6.4. Problem. From 1984 to 1985, The mean height of 15 to 18-year-old males from Chile was 172.36 cm, and the standard deviation was 634 cm. Let y equals the height of 15 to 18-year-old males from 1984 to 1985. Then yn 172.36, 634. The mean height of 15 to 18-year-old males from Chile from 2009 to 2010 was 170 cm with a standard deviation of 628 cm. Male heights are known to follow a normal distribution. Let x equals the height of a 15 to 18-year-old male from Chile in 2009 to 2010. Then xn 170, 628. Find the z-scores for x equals 160, 58 cm and y equals 162, 85 cm. Interpret each z-score. What can you say about x equals 160, 58 cm and y equals 162, 85 cm as they compare to their respective means and standard deviations? Solution. The z-score for x equals minus 160. 58 is z equals 15. The z-score for y equals 162. 85 is z equals 15. Both x equals 160. 58 and y equals 162. 85 deviate the same number of standard deviations from their respective means and in the same direction. Try it 6-4. In 2012, 1,664,479 students took the SAT exam. The distribution of scores in the verbal section of the SAT had a mean micro equals 496 and a standard deviation sigma equals 114. Let x equals a SAT exam verbal section score in 2012. Then xn 496, 114. Find the z-scores for x1 equals 325 and x2 equals 366. 21. Interpret each z-score. What can you say about x1 equals 325 and x2 equals 366? 21. As they compare to their respective means and standard deviations. Example 6-5. Suppose x has a normal distribution with mean 50 and standard deviation 6. About 68% of the x values lie within one standard deviation of the mean. Therefore, about 68% of the x values lie between 1 sigma equals 1, 6 equals 6 and 1 sigma equals 1, 6 equals 6 of the mean 50. The values 56 equals 44 and 50 plus 6 equals 56 are within one standard deviation from the mean 50. The z-scores are 1 and plus 1 for 44 and 56, respectively. About 95% of the x values lie within two standard deviations of the mean. Therefore, about 95% of the x values lie between 2 sigma equals 2, 6 equals 12 and 2 sigma equals 2, 6 equals 12. The values 50, 12 equals 38 and 50 plus 12 equals 62 are within two standard deviations from the mean 50. The z-scores are 2 and plus 2 for 38 and 62, respectively. About 99.7% of the x values lie within three standard deviations of the mean. Therefore, about 99.7% of the x values lie between 3 sigma equals 3, 6 equals 18 and 3 sigma equals 3, 6 equals 18 from the mean 50. The values 50, 18 equals 32 and 50 plus 18 equals 68 are within three standard deviations of the mean 50. The z-scores are 3 and plus 3 for 32 and 68, respectively. Try it 6-5. Suppose x has a normal distribution with mean 25 and standard deviation 5. Between what values of x do 68% of the values lie? Example 6. 6. Problem. From 1984 to 1985, the mean height of 15 to 18-year-old males from Chile was 172.36 cm, and the standard deviation was 634 cm. Let y equals the height of 15 to 18-year-old males in 1984 to 1985. Then yn 172, 36, 634. About 68% of the y values lie between what two values? These values are, the z-scores are, respectively. About 95% of the y values lie between what two values? These values are, the z-scores are, respectively. About 99. 7% of the y values lie between what two values? These values are, the z-scores are, respectively. Solution. About 68% of the values lie between 166, 2 cm and 178, 7 cm. The z-scores are 1 and 1. About 95% of the values lie between 159, 68 cm and 185, 4 cm. The z-scores are 2 and 2. About 99. 7% of the values lie between 153, 34 cm and 191, 38 cm. The z-scores are 3 and 3. Try at 6, 6. The scores on a college entrance exam have an approximate normal distribution with mean. Micro equals 52 points and a standard deviation. Sigma equals 11 points. About 68% of the y values lie between what two values? These values are, the z-scores are, respectively. About 95% of the y values lie between what two values? These values are, the z-scores are, respectively. About 99. 7% of the y values lie between what two values? These values are, the z-scores are, respectively. The shaded area in the following graph indicates the area to the left of x. This area is represented by the probability p, xx. Normal tables, computers, and calculators provide or calculate the probability p, xx. This diagram shows a bell-shaped curve with uppercase X at the extreme right end of the x-axis. The x-axis also contains a lowercase x about 1/4 of the way across the x-axis from the right. The area under the bell curve to the right of the lowercase x is shaded. The label states, shaded area represents probability p, xx. Figure 6.4. The area to the right is then p, xx, equals 1p, xx. Remember, p, xx equals area to the left of the vertical line through xp. xx equals 1p, xx equals area to the right of the vertical line through x. Pxx is the same as px less or equal to x, and pxx is the same as px greater or equal to x for continuous distributions. Calculations of probabilities. Probabilities are calculated using technology. There are instructions given as necessary for the T83+ and T84 calculators. Note, to calculate the probability, use the probability tables provided in Appendix H tables without the use of technology. The tables include instructions for how to use them. Example 6. 7. If the area to the left is 0, 228, then the area to the right is 1, 0, 228 equals 0, 9772. Try at 6, 7. If the area to the left of x is 0, 12, then what is the area to the right? Example 6, 8. The final exam scores in a statistics class were normally distributed with a mean of 63 and a standard deviation of 5. Problem. Find the probability that a randomly selected student scored more than 65 on the exam. Solution. A. Let x equals a score on the final exam. xn, 63, 5, where mu equals 63 and sigma equals 5. Draw a graph. Then find px65. px65 equals 0, 34, 46. This diagram shows a bell-shaped curve with 63 located at the center of the x-axis, and 65 located a short distance to the right of 63. The area under the bell curve to the right of 65 is shaded. The label states, shaded area represents probability uppercase P, x65 equals 0, 34, 46. Figure 6. 5. The probability that any student selected at random scores more than 65 is 0. 3446. Using the T83, 83 plus 84, 84 plus calculator. Go into second DISTR. After pressing second DISTR, press 2, Normalkt. The syntax for the instructions are as follows. Normalkt, lower value, upper value, mean, standard deviation for this problem. Normalkt 65 1E99 63 5 equals 0 3446. You get 1E99 equals 1099 by pressing 1, the EA key, a second key, and then 99. Or you can enter 1099 instead. The number 1099 is way out in the right tail of the normal curve. We are calculating the area between 65 and 1099. In some instances, the lower number of the area might be 1E99 equals 1099. The number 1099 is way out in the left tail of the normal curve. Historical note: the t-probability program calculates a z-score and then the probability from the z-score. Before technology, the z-score was looked up in a standard normal probability table because the math involved is too cumbersome to find the probability. In this example, a standard normal table with area to the left of the z-score was used. You calculate the z-score and look up the area to the left. The probability is the area to the right. Z equals 65, 635, equals 04. Area to the left is 0, 6554. P x 65 equals P z 04 equals 10. 6554 equals 0, 3446. Using the T83, 83 plus 84, 84 plus calculator. Find the percentile for a student scoring 65. Press second DISTR. Press 2, Normalkt. Enter lower bound, upper bound, mean, standard deviation followed by. Press Enter. For this example, the steps are: second DISTR, 2, Normalkt 65 1, second E99635, Enter. The probability that a selected student scored more than 65 is 0. 3446. To find the probability that a selected student scored more than 65, subtract the percentile from 1. Problem. B. Find the probability that a randomly selected student scored less than 85. Solution. B. Draw a graph. Then find P x 85 and shade the graph. Using a computer or calculator, find P x 85 equals 1 Normalkt 0 85 63 5 equals 1 rounds to 1. The probability that one student scores less than 85 is approximately 1, or 100%. Problem. C. Find the 90th percentile, that is, find the score K that has 90% of the scores below K and 10% of the scores above K. Solution. C. Find the 90th percentile. For each problem or part of a problem, draw a new graph. Draw the x-axis. Shade the area that corresponds to the 90th percentile. Let K equals the 90th percentile. The variable K is located on the x-axis. P, xk, is the area to the left of K, the 90th percentile K, separates the exam scores into those that are the same or lower than K and those that are the same or higher. 90% of the test scores are the same or lower than K, and 10% are the same or higher. The variable K is often called a critical value. K equals 69. 4. This is a normal distribution curve. The peak of the curve coincides with the point 63 on the horizontal axis. A point, K, is labeled to the right of 63. A vertical line extends from K to the curve. The area under the curve to the left of K is shaded. This represents the probability that X is less than K. P xk equals 0.90. Figure 6.6. The 90th percentile is 69. 4. This means that 90% of the test scores fall at or below 69. 4 and 10% fall at or above. To get this answer on the calculator, follow this step. Using the T83, 83 plus 84, 84 plus calculator. Inv norm in second DISTR. Inv norm, area to the left, mean, standard deviation. For this problem, inv norm 0, 90,635 equals 69. 4. Problem D. Find the 70th percentile, that is, find the score K such that 70% of scores are below K and 30% of the scores are above K. Solution. D. Find the 70th percentile. Draw a new graph and label it appropriately. K equals 65. 6. The 70th percentile is 65. 6. This means that 70% of the test scores fall at or below 65. 5 and 30% fall at or above. Inv norm 0. 70,635 equals 65. 6. Try it 6-8. The golf scores for a school team were normally distributed with a mean of 68 and a standard deviation of 3. Find the probability that a randomly selected golfer scored less than 65. Example 6-9. A personal computer is used for office work at home, research, communication, personal finances, education, entertainment, social networking, and a myriad of other things. Suppose that the average number of hours a household personal computer is used for entertainment is 2 hours per day. Assume the times for entertainment are normally distributed, and the standard deviation for the times is half an hour. Problem A. Find the probability that a household personal computer is used for entertainment between 1/8 and 2/75 hours per day. Solution. Let X equals the amount of time in hours a household personal computer is used for entertainment. Xn 205, where mu equals 2 and sigma equals 0.5. Find P1, 8x2, 75. The probability for which you are looking is the area between x equals 1/8 and x equals 275. P1, 8x275 equals 0. 5886. This is a normal distribution curve. The peak of the curve coincides with the point 2 on the horizontal axis. The values 1/8 and 275 are also labeled on the x-axis. Vertical lines extend from 1/8 and 275 to the curve. The area between the lines is shaded. Figure 6-7. Normoct 182, 5 equals 0. 5886. The probability that a household personal computer is used between 1/8 and 275 hours per day for entertainment is 0. 5886. Problem B. Find the maximum number of hours per day that the bottom quartile of households uses a personal computer for entertainment. Solution. B. To find the maximum number of hours per day that the bottom quartile of households uses a personal computer for entertainment. Find the 25th percentile, K, where P x K equals 0. 25. This is a normal distribution curve. The area under the left tail of the curve is shaded. The shaded area shows that the probability that x is less than K is 0.25. It follows that K equals 1. 67. Figure 6-8. Inv norm 0, 2525 equals 1. 66. The maximum number of hours per day that the bottom quartile of households uses a personal computer for entertainment is 1. 66 hours. Try it 6-9. The golf scores for a school team were normally distributed with a mean of 68 and a standard deviation of 3. Find the probability that a golfer scored between 66 and 70. Example 610. In the United States, the ages 13 to 55 plus of smartphone users approximately follow a normal distribution with approximate mean and standard deviation of 36 9 years and 13 9 years respectively. Problem A. Determine the probability that a random smartphone user in the age range 13 to 55 plus is between 23 and 64, 7 years old. B. Determine the probability that a randomly selected smartphone user in the age range 13 to 55 plus is at most 58 years old. C. Find the 80th percentile of this distribution and interpret it in a complete sentence. Solution. A Normalct 2364, 736, 913, 9 equals 0, 8186. B Normalct 1099, 50, 836, 913, 9 equals 0, 8413. C Inv Norm 0, 8036, 913, 9 equals 48, 6. The 80th percentile is 48. 6 years. 80% of the smartphone users in the age range 13-55 plus are 48, 6 years old or less. Try it 610. Use the information in example 610 to answer the following questions. Find the 30th percentile and interpret it in a complete sentence. What is the probability that the age of a randomly selected smartphone user in the range 13 to 55 plus is less than 27 years old? Example 611. In the United States, the ages 13 to 55 plus of smartphone users approximately follow a normal distribution with approximate mean and standard deviation of 36, 9 years and 13 9 years respectively. Using this information, answer the following questions, round answers to one decimal place. Problem. A. Calculate the interquartile range, IQR. B. 40% of the smartphone users from 13 to 55 plus are at least what age? Solution. A. IQR equals Q3, Q1. Calculate Q3 equals 75th percentile and Q1 equals 25th percentile. Inv Norm 0, 7536, 913, 9 equals Q3 equals 46, 2754. Inv Norm 0, 2536, 913, 9 equals Q1 equals 27, 5246. IQR equals Q3, Q1 equals 18.8. B. Find K where P, x greater or equal to K equals 0. 40 at least translates to greater than or equal to 0. 40 equals the area to the right. Area to the left equals 1. 0. 40 equals 0.60. The area to the left of K equals 0.60. Inv Norm 6036, 913, 9 equals 40, 4215. K equals 40. 40% of the smartphone users from 13 to 55 plus are at least 40. 4 years, try it 611. 2,000 students took an exam. The scores on the exam have an approximate normal distribution with a mean mu equals 81 points and standard deviation sigma equals 15 points. Calculate the first and third quartile scores for this exam. The middle 50% of the exam scores are between what two values? Example 612. A citrus farmer who grows mandarin oranges finds that the diameters of mandarin oranges harvested on his farm follow a normal distribution with a mean diameter of 85 cm and a standard deviation of 24 cm. Problem. A. Find the probability that a randomly selected mandarin orange from this farm has a diameter larger than 60 cm. Sketch the graph. B. The middle 20% of mandarin oranges from this farm have diameters between and. C. Find the 90th percentile for the diameters of mandarin oranges and interpret it in a complete sentence. Solution. Le. Normalct 6 1099 5. 850 equals 0, 2660. This is a normal distribution curve. The peak of the curve coincides with the point 2 on the horizontal axis. The values 1, 8, and 2, 75 are also labeled on the x-axis. Vertical lines extend from 1, 8, and 2, 75 to the curve. The area between the lines is shaded. Figure 6-9. B1 020 equals 080. The tails of the graph of the normal distribution each have an area of 40. Find K1, the 40th percentile, and K2, the 60th percentile. 040 plus 020 equals 060. K1 equals Inv Norm 0, 405, 850. 24 equals 579 cm. K2 equals Inv Norm 0, 605, 850/24 equals 591 cm. C616. 90% of the diameter of the mandarin oranges is at most 6.16 cm. Try at 612. Using the information from example 612, answer the following. The middle 40% of mandarin oranges from this farm are between and. Find the 16th percentile and interpret it in a complete sentence. Stats Lab. Normal distribution, lap times. Class time, names, student learning outcome. The student will compare and contrast empirical data and a theoretical distribution to determine if Terry Vogel's lap times fit a continuous distribution. Directions. Round the relative frequencies and probabilities to 4 decimal places. Carry all other decimal answers to 2 places. Collect the data. Use the data from Appendix C. Use a stratified sampling method by lap, races 1 to 20, and a random number generator to pick 6 lap times from each stratum. Record the lap times below for laps 2 to 7. Table 6. 1. Construct a histogram. Make 5 to 6 intervals. Sketch the graph using a ruler and pencil. Scale the axes. Blank graph with relative frequency on the vertical axis and lap time on the horizontal axis. Figure 6. 10. Calculate the following. Letter 1D465. Equals. As equals. Draw a smooth curve through the tops of the bars of the histogram. Write 1 to 2 complete sentences to describe the general shape of the curve. Keep it simple. Does the graph go straight across? Does it have a V shape? Does it have a hump in the middle or at either end, and so on? Analyze the distribution. Using your sample mean, sample standard deviation, and histogram to help. What is the approximate theoretical distribution of the data? X. How does the histogram help you arrive at the approximate distribution? Describe the data. Use the data you collected to complete the following statements. The IQR goes from 2. IQR equals Q3, Q1. The 15th percentile is. The 85th percentile is. The median is. The empirical probability that a randomly chosen lap time is more than 130 seconds is. Explain the meaning of the 85th percentile of this data. Theoretical distribution. Using the theoretical distribution, complete the following statements. You should use a normal approximation based on your sample data. The IQR goes from 2. IQR equals. The 15th percentile is. The 85th percentile is. The median is. The probability that a randomly chosen lap time is more than 130 seconds is. Explain the meaning of the 85th percentile of this distribution. Discussion questions. Do the data from the section titled Collect the Data. Give a close approximation to the theoretical distribution in the section titled Analyze the Distribution. In complete sentences and comparing the result in the sections titled Describe the Data and Theoretical Distribution, explain why or why not. Stats Lab. Normal distribution, pinky length. Class time, names. Student learning outcomes. The student will compare empirical data and a theoretical distribution to determine if data from the experiment follow a continuous distribution. Collect the data. Measure the length of your pinky finger in centimeters. Randomly survey 30 adults for their pinky finger lengths. Round the lengths to the nearest 0.5 cm. Table 6.2. Construct a histogram. Make 5 to 6 intervals. Sketch the graph using a ruler and pencil. Scale the axes. Blank graph with frequency on the vertical axis and length of finger on the horizontal axis. Figure 6.11. Calculate the following. Letter 1D465. Equals. As equals. Draw a smooth curve through the top of the bars of the histogram. Write 1 to 2 complete sentences to describe the general shape of the curve. Keep it simple. Does the graph go straight across? Does it have a V shape? Does it have a hump in the middle or at either end, and so on? Analyze the distribution. Using your sample mean, sample standard deviation, and histogram, what was the approximate theoretical distribution of the data you collected? X. How does the histogram help you arrive at the approximate distribution? Describe the data. Using the data you collected, complete the following statements. Hint. Order the data. Remember, IQR equals Q3, Q1. IQR equals the 15th percentile is, the 85th percentile is, median is. What is the theoretical probability that a randomly chosen pinky length is more than 5 cm? Explain the meaning of the 85th percentile of this data. Theoretical distribution. Using the theoretical distribution, complete the following statements. Use a normal approximation based on the sample mean and standard deviation. IQR equals the 15th percentile is, the 85th percentile is, median is. What is the theoretical probability that a randomly chosen pinky length is more than 5 cm? Explain the meaning of the 85th percentile of this data. Discussion questions. Do the data you collected give a close approximation to the theoretical distribution? Incomplete sentences, and comparing the results in the sections titled Describe the Data and Theoretical Distribution. Explain why or why not.